Okay, so we're exploring a little bit. We're combining the multiple rule and the power rule to see if we can't do this a little bit faster than having to take 4 times. Like if we can just do all that in one shot, essentially, it would make our lives a whole lot easier. So if we looked at what I'm hoping here, when you took the derivative, I want you to pause the video and then go and do these right now. Take the derivative. Here's what I hope you were getting here. Now, after you look at these, if there's a quick way to get it, I mentioned it in the last video a little bit, but here, if you can create your own rule, I want you to pause the video and create your own rule. If you may get it wrong, don't worry, I'll show you in a minute. This is what you should be getting for that rule. You take the constant multiplier times the power, and then you multiply by x to the one less power than before. So here, if I put it into words, this is what that would look like. So let's look at example 6. Example 6, then, we're going to go in. Again, I'm going to give you the same advice that I did before. I want you to rewrite if possible. This one does not, the first one doesn't need a rewrite. You can just go straight into the rule. But for the second one, so I was talking about this one here, the second one, you definitely do. I would rewrite it first, and you write 5/3 x to the negative 4. For the third one, be really careful because it's not just the x that's raised to the fourth, it's the whole thing. So when you rewrite this, it's going to be 5/3 to the fourth power, which is 81. Don't ignore that part. And then that's going to be x to the negative 4. So that really matters. For this one here, I would rewrite it as f of t is equal to 2/5, and then bring up the t cubed. For f of t, again, be super careful. One of them, the t was only being raised to the negative third. This next one, the whole thing, including the 5, is raised to the negative third. So it's going to be essentially 2 times 5t to the third power. And then I would then continue further. 5 to the third is 125 times 2 is 250 t to the third, and then take the derivative. Same for the next one. Y is equal to the negatives on the outside, so that's still part of it. Everything else is being squared. So I'm going to square 9, and square the 4 gives me 16. I know I said square and said 9. I meant square the 3 and you get a 9. And then you get x squared. And I do write it as a coefficient, that the 916 as a coefficient. It just makes it easier to use the previous rule that we just got. And then you just combine the power rule with the multiplier rule. You take the power times the coefficient. For this, for the first one, y prime is equal to 1/2 times 4 is 2. X to the 1/2 minus 1 is negative 1/2. And if I don't require you to simplify, you don't have to. But you could write it, or y prime is equal to 2 over the square root of x. You could also rationalize, but it's unnecessary. You do not need to do that. Now try the rest of them. Pause the video and try them, and then you can come back and take a look. That is what I'm getting for example 6. Hopefully we agree. All right. For the next one, another common rule. So we're doing both the sum and the difference for this one. The sum and the difference rule is based on the limit rules again. Don't forget derivatives are defined by limits. So the properties that apply to limits also apply to derivatives. So if I'm going to prove each one of them, what's useful about this is that if you have like you're taking the derivative of something that has multiple terms, it means I can take the derivative one term at a time. So it lets us take the derivative of one term at a time. So hopefully that makes our lives a little bit easier. So that is the proof for it. Again, I'm going to do it for one of them. You're going to try the other one on your own. Let's do it for the positive one. It's done very similar for both of them. So the limit as h approaches 0 is going to be, I'm going to substitute in, so I get f of x plus h plus g of x plus h minus f of x plus g of x over h. Now we're going to do a little bit of rearranging because I'm going to take this f of x plus h minus the f of x and group together, and then I'm going to do the same for the g of x plus h of x. So that means let's rearrange things a little bit. The limit as h approaches 0, I'm going to group the f of x plus h minus the f of x, and then we have plus g of x plus h minus, don't forget you have to distribute the negative there in the middle. Here, this negative distributes to both the f of x and the g of x. G of x all over h. That h has to essentially go into every single one of those terms. So I could rewrite these as the limit as h approaches 0 of f of x plus h minus f of x over h plus g of x plus h minus g of x over h. I'm going to put a bracket because it's not all naturally grouped together anymore. But remember, the limit property means I can take the limit of those two terms separately. So the limit as h approaches 0 of f of x plus h minus f of x over h plus the limit as h approaches 0 of g of x plus h minus g of x over h. Each of those are the definitions for each of their derivatives. So that gives me the one on the left, the one I'm highlighting in yellow, is defined as f prime of x. Then we have plus, and then the one I'm highlighting in blue right now, that one is defined as g prime of x. So g prime of x. And there you have it. You end up. Now, I want you to try to prove this one on your own, okay? That one you can do either on the side or somewhere else. Pause the video. It's done in a very similar way. It just has a negative in between the f of x plus h minus g of x plus h, and then the same thing in between the two terms. What does that mean in terms of our example here? Our example, it means that we can take each of these separately. So when we take the derivative, instead of having to use this long limit definition, we can apply the derivative dy dx. Essentially, I do not want you to write. I'm just writing this for this example only. I can take the derivative of each individual term, one at a time. So minus d dx, I'm taking the derivative with respect to x of every single term one at a time. Now, you would be doing that mentally, but just to make it explicit here. So that gives us, the first term is going to give me a 4x cubed minus 6x And then the derivative of 5 is just 0. That's the constant. For the second one, same thing again. Sometimes it behooves you to kind of rewrite them. For the third one, same thing. I would probably do a rewrite first, but let's look at the first one. It's going to give me y prime is equal to, the power is 5, and the coefficient is negative 1 over 20. Don't forget, I could rewrite that part as negative 1 over 20 x to the 5th, like that, if that helps you think of it. So that's going to give me negative, I take negative 1 over 20 times 5 is going to give me negative 1/4 x to the 4th plus 12x squared minus 5. I'm taking the derivative of one term at a time. For the next one, you would do a little bit of a rewrite and then take the derivative. Because this 2x is a monomial, I'm going to make it go into every term. So we're going to first, I'm not taking the derivative yet, so don't write f prime. I'm just going to rewrite it as 2t. Oh, that's supposed to be t's. That's a typo. Sorry, change that to t's for all of them. I'll have to go back and fix that. All right, so 2t squared minus 2 plus 7. Oh, that's not even 2. I'm so distracted by all of that. Look at that. It's going to be minus 1 because 2 over 2. And then plus 7 over 2 t to the negative 1. And then you're going to, there's 3 terms. We're going to take the derivative of each term individually. So then we get f prime of t is equal to 4t. The derivative of negative 1 is just 0, right? So just be careful with that. And then we have minus 7 over 2 t to the negative 2. Now pause it and try the next one. If you need to, you can rewrite. I know that this is 3x to the 1/3, if that helps. All right. This is what I'm getting for that one. And if you want to rewrite it, g prime of x 1 over the cube root of x squared and then minus 18x, you could, right? Don't forget the derivative of the 15 is 0. That's a constant function. All righty.